process on how to configure a Raspberry Pi 5 to become a mini router in my house. As you can see, the Raspberry Pi has already been configured to work. I have already downloaded all the updates and the Raspberry Pi is ready to be configured. So what I got here for this setup is I have the modem provided by the ISP, the active Raspberry Pi, and I also have this DHCP 591 PCIe to 2.5 gigabyte Ethernet port hat for the Raspberry Pi. So how the setup is going to work is I'm going to connect the Raspberry Pi to my ISP modem. This will allow the connection to the internet just like any other device in the house. However, the Raspberry Pi is going to be configured to become a mini router. What I'm also going to do is I'm going to install this ZDE hat on the Raspberry Pi, and then I'm going to configure this card to become the second Ethernet port on the Raspberry Pi. And that secondary port is going to be connected to the switch in my house to enable the physical connection from the switch to the Raspberry Pi, let the Raspberry Pi do all the routing of the internal private IP addresses and convert it into a public IP address that then will be connected to the home modem and let the devices access to the internet. The modem is already doing something like that, but let's say for example, if I connect my computer to the wireless connection in the modem, it's not blocking or filtering anything. It's just allowing everything out, everything in. So the intent is to use this Raspberry Pi 5 to become a router and protect every device in the internal private network. I will be configuring another Raspberry Pi to become a firewall, but to begin with, I'm going to configure this one to become a router. So all the private IP addresses that are connected, that are configured in the switch, and the devices connected to those IP addresses can safely access the internet after all the traffic has been filtered through the router. The devices that I'll be configuring in this private network. I have a VLAN that will be created for computers, one for servers, one for cameras, and one for my AI system. The breakdown of this is computers is going to be VLAN 14 in the 172.16.14/27 range. Servers is going to be 172.17.21/27, and the cameras are going to be in the range of 172.18.28/27. And I am using a /27 CIDR block. That will create a subnet of 255.255.255.224, and it creates 32 IP addresses in that subnet. The IP addresses go from 0 all the way through 31. And let me explain where this 0 comes from and how it is used, because I don't know if you have, but I have never seen an IP address assigned to a .0 before. And that is because the 0 in the CIDR block is a network address. And what is the network address? Well, the network address is used internally by the devices in the network to find the routing tables. So in this case, in this range 172.16.14, the devices in the network will look for the .0 to know what subnet they belong to, and then they will jump to the first usable IP address, which in this case it's .1, which I will be using as the default gateway. So that is the purpose of the 0. It is reserved for that specific purpose to find the routing tables by the devices inside the network, and of course it can never be used for any other purpose because it's not routable. Now that we have this 0 out of the way, that tells me that out of these 32 IP addresses, I have 31 left that can be used. And out of those 31 IP addresses, I have to use one for the default gateway. That leaves 30 available IP addresses. I have to use one for the broadcast address, and that leaves only 29 usable IP addresses. And that's what this is. So without taking into consideration the 1 and the 31, I know I have the first IP address that I can assign to a device as the 172.16.14.2, and I can go up to 30. And I know that's the range of 29 IP addresses that I can use in my private network for the computers. Right now, I don't have 29 computers that I will be connecting to this network, but if I ever do, I know I have allowance up to 29. And it's going to be the same thing for the servers and the cameras. Now, when it comes to the AI system, I have an AI agent that I'll be using for analytics and assistance in, everything that we use AI for right now. And that is going to be VLAN 35, and it's going to be in the range of 172.19.35/30 CIDR block. This gives me a total of 4 IP addresses. It is the same as with any other address. We have the network address as 0. So when we take that out of the list, that leaves 3 usable IP addresses. I need to use 1 for the default gateway. That leaves 2 available IP addresses. And then I need to use 1 for the broadcast address. That leaves a single IP address that can be assigned to a device. And this is exactly what I want, because this AI system is going to be completely separate from cameras, servers, and computers. So that is why I only need 1 unique IP address. And all these VLANs are going to be created in the switch, and the switch is going to be doing all the inter-VLAN routing. I just wanted to show what the network topology is going to be inside the private network. When I set up the Raspberry Pi, I enable SSH to allow me to remotely connect to it from my house computer. All the configuration done in this scenario is going to be done via CLI. So what I'm going to do is I'm going to go back to my computer. I'm going to SSH into the Raspberry Pi 5, and I'm going to start the process. Alright, and before I SSH into the Raspberry Pi, I went ahead and installed the hat. I want to SSH into the Raspberry Pi and check for the Ethernet port, and then I'll connect the hat and make sure the Raspberry Pi recognizes the secondary Ethernet port. So I have connected the flex cable on the Raspberry Pi, and once I confirm the Raspberry Pi is up, running, and good, I will connect the flex cable to the hat, and then I'll check the connections to make sure I have 2 Ethernet ports. Going to SSH into the Raspberry Pi. Okay, now I'm going to open terminal, and I'm going to SSH into the mini router. So it's going to be mini router.land, enter, ask me for the password, and I am in. Okay, and now I'm going to clear the screen. And now what I'm going to do is I'm going to check and see how many Ethernet ports I see. And I see 1, which is what I would expect. So I only see the Ethernet port in the Raspberry Pi board itself. So what I'm going to do is I'm going to connect the flex cable on the hat. And then I'm going to run this command line again. And the expectation is that I will see another Ethernet port. I'm going to install the flex cable, and you're going to see a little light here if it works. So I'm going to close it. Alright, and now if you see the light is on, so I should be able to see the secondary port from the hat on the Raspberry Pi. So I'll go back to my SSH session, and I'm going to run the command line again. Now I'm going to run the command line again, IP link, and I do not see it yet. So what I'm going to do is I'm going to reboot the Raspberry Pi and wait for it to come back and run this command line again. Raspberry Pi rebooted. I'm going to clear the screen, and I'm going to log back into it. Password. Okay. Clear the screen again. Run IP link. And now, as you can see, I have the original Ethernet port. I have the Ethernet port from the hat. And now that I have identified the ports for the Raspberry Pi and the Raspberry Pi hat, I'm going to go over the topology for this setup. So I'm going to bring this picture in this text file into focus. And the way it works now is, as you can see, the Raspberry Pi is connected to the ISP modem. And this is getting an IP address of 192.168.40.76, as you can see here. And also, if I look at the computer that I'm working on and check the IP address, I can see that the IP address is a 192.168.40.164. And by that logic, any other device in the home network will have an IP address of a 192.168.40.blah /24 CIDR, which gives us a 255.255.255.0 subnet. And in order for me to set this properly, I'm going to configure the router in a whole new network. I will keep it simple for management, so I will assign the range of the 192.168, and the third octet will be different. It will be 70. And I am going to use a /29 CIDR, which creates a subnet of 255.255.255.248. I had to go with a /29 CIDR block because I need at least 2 IP addresses, and I cannot use a /30 CIDR block because that creates a subnet with only one IP address that can be assigned to a device. I will be hard coding the IP address 192.168.70.1 to the Ethernet port in the hat, which is this one right here. And I will hard code the IP address 192.168.70.2 to the switch in the private network. The built-in Ethernet port in the Raspberry Pi will remain untouched. This will continue to get its IP address from the ISP modem via DHCP. This port right here is just a door from the private network out to the internet. The IP address this is configured on is not important for this setup. How the traffic will flow is, inside the private network, a computer will send a packet to the switch, then the switch will send the same packet to the hat. The hat will masquerade the private IP address. In this case, it would use the IP address assigned to the Ethernet port in the Raspberry Pi. And then the traffic will go out to the ISP modem and from the ISP modem to the internet. The same thing will happen to the traffic coming back from the internet to the computer in the private network. I will add a firewall to the connection between the mini router and the switch, but for right now, this router will serve as the first filter I have in place to net the internal traffic and keep the private network private. Then the switch will handle all the ACLs to block and or allow traffic in and out of the devices connected to the different VLANs in the private network. Let me jump back into the SSH session and start the configuration. I'm going to clear this screen and I'm going to bring the information for the Ethernet ports back up. And now I'm going to paste this command line. And if you notice here, the hat Ethernet port is labeled as ETH1, and that is the one that I am going to configure here with an IP address of 192.168.70.1, and this is going to be a /29 IP address. I hit enter. As you can see, connection private VLAN successfully added. Run this other command line, and the connection is now active. Next up, I'm going to enable routing by configuring the persistent forwarding in the Raspberry Pi. Hit enter. And the last part in the process is going to be to configure the NAT in the Raspberry Pi, add the static route to my local VLANs, which will be configured in a switch, and make the configuration permanent. So whenever I have to reboot or lose power on the Raspberry Pi and this restarts, whatever the case may be, I don't have to go through this process all over again, but it will be saved in the SD card. I'm going to go ahead and do that, and then I'll show the routing summary. And now I want to explain where you can get the rest of the configuration, since this won't be shown in this video. You can download the complete configuration for this mini router, and I have also included the switch configuration for those using a Cisco switch. All of this is available in a single file that you can download from the jleo.com. Once you are on the site, click on the digital downloads button. Then scroll all the way down the page until you see the downloadable file labeled Raspberry Pi 5 router switch configuration. And as you can see, I have reduced the price to make the file more affordable and easier to access. So click on the image and it will take you to the page that explains what the lab does and gives you the option to add it to your cart. After adding the file to your cart, complete the payment process and you will receive an email with a link to download the PDF file that includes all the command lines and step-by-step instructions you need to complete for this lab. And this is the file you'll be able to download, and it is a 9-page document that details step-by-step command line configuration and also the explanation of why each command line is used and what it does. I've also included testing steps to help you verify that your configuration is working properly as you go. And now that you've seen where to download the lab file, where I'll be running the final test and see the mini router and switch in action as they protect the private network, you'll also see the device is successfully receiving an IP address from the built-in DHCP server in the switch. All those setups, how to create a DHCP locally in the switch, and the subnetting for the IP addresses are listed in this documentation. Okay, let's go back to the rest of the video. So the router now has been configured. So I'm going to check the routing configuration by running the command line IP route. And I can see all the IP addresses that I set up. 40.76, which is the default Ethernet port in the Raspberry Pi. The traffic is going to be pushed from the hat to the 192.168.70.2, which is the switch. 192.168.70.1, which is the Raspberry Pi hat, is the source. So yeah, everything seems to be fine. Now the last thing I'm going to check here is the NFT list rule set. Accepted, it's masqueraded on Ethernet 0. Alright, I'm good. Now I want to test it. I'm going to connect the switch to the Raspberry Pi. It's connected to the hat. And I can see the switch coming up. And now let's see if I can ping the router from the switch. The IP address is 192.168.70.1. And yep, it is successful. Now let's see if I can ping Google from the switch. .8. Yep, I have access to the internet. If I look at the IP address of the switch, it's going to be 192.168.70.2, just like we set up in the Raspberry Pi. Okay, so now I know the switch is online, the connection to the Raspberry Pi is enabled. I can ping the Raspberry Pi and I can get online from the switch, which means that the routing is working. However, I'm going to run another test, and now it's from the Raspberry Pi. I'm going to see if I can ping the switch .2, which is the IP address of the switch. Yep, successful. And now let me see if I can ping the default gateway of the computers. So 172.16.14.1. And it knows where it goes to. So the next hop is going to be 170.1, which is my router. So now what I need to do is I need to connect the computer and see if I can get to it. So now I log into this Windows computer. As you can see, it says that I don't have internet access. So I'm going to open settings and I can confirm that the Wi-Fi is turned off and the Ethernet is turned off. It's set up to receive an IP address automatically from DHCP. And if I open command prompt, I can check and make sure I don't have any IP address assigned to this computer just yet. So what I'm going to do is I'm going to run ipconfig, and you can see there's nothing, no internet, no Ethernet. There are no IP addresses associated with this computer as of right now. So I'm going to connect the computer to the switch and wait for it to receive an IP address from the DHCP scope that is configured in it. So I'm going to go ahead and do that. You can see it's identifying the connection and it has received a connection. Now let me check and see if I get an IP address from the switch. And there you go. It's giving me the first available IP address that the DHCP scope can give, which is 172.16.14.2. If I try to ping Google, it's successful. And if I scroll up, you can see it's the 172.16.14.2 IP address, the 172.16.14.1 for the default gateway. So everything seems to be working as expected. All right, what I'm going to do next is I'm going to unplug the computer from the switch to remove internet access. And now you can see it says no internet access. So I'm going to run ipconfig again to confirm that all the configuration has been cleared. As you can see, there is no IP address associated with the computer. Now I am going to turn Wi-Fi on. So it's on. I'm going to run ipconfig again. And as you can see, it's giving me the IP address from the ISP modem, which is 192.168.40.40. Okay, I am going to disconnect from wireless and plug the computer back into the switch to clear the IP address I got from Wi-Fi and get another IP address in the 172 range that the switch will be giving. So I can see I'm connected to the switch again. I'm going to run ipconfig, and there you go. Now I have the 172.16.14.2 address, and if I scroll up, I also see the 192.168.40.40 that it was assigned to the computer by the ISP modem when I turned Wi-Fi on. Alright, so that's good. Now this proves that the configuration of the switch is working. The local DHCP server and the switch is working as expected since it's giving IP addresses out properly. Okay, I'm going to go down and ping Google again. And I can see that it's pinging, but I'm going to take it a step further and I'm going to download an app while connected to the 172.16.14.2 IP address. So I'm going to type in PuTTY in the search bar. It's going to take me to the Microsoft Store. And from here, I am going to install PuTTY. That also confirms that the routing is working since I'm going from a private 172 IP address to a 192 address in the Raspberry Pi hat, and from there out to the network, and I can actually download apps, which confirms all the routing information is working. So I'm gonna wait for this app to open, and now I'm going to SSH into the switch from this Microsoft computer on the 172 address. Alright, so now I'm going to accept the key and I'm going to log in. Alright, and I am in the switch. Let me see. I'm going to check show run interface VLAN 14 for the computers, and yeah, as you can see, it's in the same range as the IP address I was giving by the DHCP scope internally to the switch. Now, if I check the IP table in the DHCP scope, I can see where that one IP address assigned to my computer is the only one that the DHCP scope has given out. Alright, so all this configuration is working as I intended to. Okay, and now that we have seen that the DHCP scope created in the switch is working and is providing an IP address to the computer, and when the computer has this IP address, it's allowed to go out to the network, ping Google, download apps, so on and so forth. So what I'm going to do here is I'm going to disable in the switch the ACL that allows the computer to go out to the network. And this access control list with all the ACL configuration and the DHCP scopes and everything is listed on the documentation you can get from the jleo.com. So let me show you how to disable that ACL and try to ping Google after the ACL is disabled, and you will see how the ping at that point fails. So I'm going to get into the ACL list and I am going to remove the ACL number 11, which is the one that allows internet access to the computer IP address range on VLAN 14. And if I try to ping Google now, it fails. And there you have it. That ACL now has been removed from the switch configuration, and all the traffic from the computers trying to go out is going to be blocked at the switch level. So then I know, oh, the private network now is private, and the router is not even going to see that traffic coming from the computers without that access control list. So if I want to enable internet again, I just add that access control list back into the switch configuration under that access control list rule, and internet will be enabled back up. Okay, and now I'm back on my SSH terminal, so I'm going to clear this out. And I'm going to see if I can ping the default gateway for VLAN 14, which is the computer. So ping 172.16.14.1. Success. So now that one computer has received an IP address from the DHCP server, VLAN 14 has come alive, and now the default gateway is active. That's how I can ping it. If I try to ping the computer, I am not going to be able to. It's not going to let me, which is what I expect. So the computer can go outside to the network, but the network cannot find the computer. I can still download updates and stuff on the computer, but someone, not me, trying to get to the computer, it's not going to be able to. Even if I try to ping the computer from my current workstation, if I try to ping the computer inside the private network, I'm not able to, because it's protected inside the netting of the router. Even if I try to ping the default gateway, I'm not going to find anything, because for all intents and purposes, that network doesn't exist. Everything is behind the router and behind the ACLs in the switch. So it is private, which is what I wanted. All right, and that is it for this video. That's how you set up your router, and you can see the examples of how that works when you have a private network trying to reach out to the internet, and how you protect your private network from the outside world. So thank you for watching. I will see you in the next one.